these are your 5-2 notes on dividing polynomials. So 5-1 focused on multiplying and dividing monomials, but we also multiplied, added, and subtracted polynomials. We have not divided polynomials. So remember, polynomials means that it is more than one term. And so if you look at these examples down here, example 1 has a trinomial divided by a monomial, and example 2 also has a trinomial divided by a monomial. So when we look at division, we do it in a couple different steps here. We're first going to look at polys divided by monos. The process is different. So a couple things when you're dividing a poly by a mono, you want to write it as several fractions over the monomial. You guys are going to really want to skip steps here, and I'm going to strongly suggest easiest problems to do. But if you try to skip these steps, you're going to make sign errors. You're going to make simplification errors that you normally wouldn't do if you would just follow the simple little step right here, that first initial step of rewriting the original as several fractions. So I know in example 1, we've got this great big polynomial. That 1 is part of the example. So you got this polynomial, and we're dividing by this monomial. So it's just one term. I know there's 2 letters, but it's just one term. So sometimes they show it like that with the division sign. Other times they're going to show it like example 2. Example 2 is showing a new way of looking at division. So it's saying multiply by that number to the -1 power. Well, in 5-1, we learned that anytime you raise something to the -1 power, it flips it. So what you're really multiplying by is the reciprocal. And when we multiply by the reciprocal, that's really division altogether. So it's just a fancy way to write down division. You're not multiplying at all. Well, you are, but you're going to multiply by the reciprocal. So anytime you see that little symbol with the -1, that just means you're dividing by that term. So we write them as several fractions over that monomial, and then we simplify each of those monomials separately. So if you look at this first example, even though it shows the division sign of -xy, common error, I'm going to show you, but I don't want you to do this. A lot of people want to just write it down like this. This is another way that they show us in the book, or they show us on a worksheet, and they're just being lazy. They're just saying, yeah, I am dividing that whole trinomial by this one monomial. But if you try to show your work that way, you're going to fall into some errors. So what I really strongly suggest, we can leave that one there, but then I also want you to put one underneath the first term and also under that third term. So we're actually dividing each term individually by that. So when I divide this first one, my eyes are just focusing on this portion right here. And we're just simplifying. So it really breaks it into 5-1 again. We're looking at how would you simplify this if it was 5-1. The sign of the variable is just like a -1 out in front of it. And so it's a +1 over a -1. That's going to leave me with a negative. I have 3 x's on top. I have 1 x on the bottom. That would leave me with 2 x's on top. I have 2 y's on top. I have 1 y on the bottom. That would leave me with 1 y. So the first of the monomials has been simplified or divided. The second one, I'm going to look at the signs again first. Negative divided by a negative makes it a positive. I have an x squared over an x. That's going to leave me with an x. And then my y's are going to cancel because I have 1 y on top, 1 y on the bottom, so they cancel out. So all I was left there was a positive x. And sometimes the leftover amount might be in the denominator. So that's where this gets really tricky. Sometimes you'll have a variable in the denominator, sometimes you won't. In these first 2, all of our leftovers were in the numerator. But if you look at the very last one here, one more time, positive and the negative is going to make the minus. There is no number part, so the 2 is just going to stay 2. The x's are going to cancel, so there's no x's anymore, but where the y is located that's still there is in the denominator. And this is where I notice kids make big errors when they write their answer and they don't show it as separate divisions. I'll get a lot of answers like this, and then they put the whole thing over y. The whole thing is not over y, only the -2 is over y. So that's why I'm telling you, do this, separate into 3, and these easy problems will not be difficult. And you'll get credit for them. I hate marking these wrong, but I will when you don't follow the suggestions that I make. Same thing here, this means multiplication. So I'm going to, wherever I see the MP, I'm just going, or the term, I'm going to divide by MP. divide by MP, divide by MP. So this is polynomial divided by monomial. And then you just simplify each one individually. So I'm looking at this whole term right here. Positive divided by positive is positive. I have 3 m's on top. I have 1 on the bottom. So the 1 would cancel, leave me with 2 on top left over. I have no n's, so the n squared, or I have no n's on the bottom. So n squared remains, and then the p's cancel. So that first term of the polynomial turns into m squared n squared, or simplifies, minus m squared n over mp. So again, the m to the second and m to the first leaves me with a negative m. There's no n's to simplify with. There's no p's to simplify with. So the n stays on top and the p stays in the bottom. And the last one right here, I'm looking at that sign. So plus, no n's. So n cubed. The p's are going to cancel. The 1p is going to cancel out that 2. So leave me with 1p on top and an m in the denominator. So this time I had 2 of them. They had denominators separately. So that is polynomial divided by a monomial. So now we're going to talk about what if it was a poly divided by another poly. So if you look at example 3 here, I have some line papers showing up here because it's important to organize our work. We're going to show our work on line paper as well. But I have this great big here. I've got this 1, 2, 3, 4, 5 term polynomial, and I'm dividing by a binomial. Now we'll learn how to divide, by trinomials and by bigger than 3, bigger than 2 later on. This is just if we have a binomial factor. So x minus 2 is the biggest that we'll divide by, a binomial. However many terms we're dividing, it just depends. There's no limit as to how big the polynomial might be that we're dividing. So when we use this synthetic division, it's really fake division. We're not going to divide at all, but it serves a purpose. This basically saves us from having to do these long division type problems. Okay, and I can demonstrate that in class of what this would look like if I showed you long division. I don't teach my Algebra 2ers long division anymore. I just feel like we got lost in it. So we just stick to the synthetic division. We use this over and over again in chapter 5. So it's easier than long division, used with the binomial divisor. So binomial, 2 terms. And notice the form is x minus r. Okay, so if it's x minus 3, it's tricky. The r value is really positive 3. If it's at x plus 3, that means there was a negative 3 in there. So you just gotta watch that minus part. Just kind of switch it in your head a little bit. The coefficient of x must be 1. So if this isn't 1, we have to fix it. I'll show you how to do that too. Those are a little trickier. And then it must be written in complete descending order. Complete descending order. Okay, descending means from the biggest to the lowest, but complete means you can't skip any. So if you look at this example, we have degree 4, degree 3, degree 2, degree 1, and then degree 0, right? 2 to the, there's no x to the 0, I should say. So complete degree of the variables. So the variables of x, or the powers of x, count down 4, 3, 2, 1, none. If any of those are missing, you have to add placeholder zeros to hold their place. That's exactly what they do. We add placeholder zeros when we add or subtract numbers, and there's not enough decimals, we put in zeros. It's a number you can add that doesn't change the effect of the problem. So we'll talk about that a little later when that applies. But right here, we had it complete. It went 4, 3, 2, 1, none. Has to go down to the constant. It has to go degree 4, degree 3, degree 2, degree 1, and then the constant. All right, so here we go. You're going to put the r value. This is your r value. So our r value is 2, and that goes up in the corner up here. Let's make a little box with it. Okay, and we're going to get rid of the variables temporarily because they're really not necessary. We really don't care about the variables right away until later on in the answer. So I'm just going to take the coefficients, the numbers out in front of this polynomial, and write them down. So I have a 1 x to the 4th, so that 1 represents x to the 4th. Negative 2 will represent how many x cubes we have. Plus 1 represents the x squareds. Minus 3 represents the x's. And plus 2 represents my constants. So then we're going to leave a space. So I use line paper. Keep it nice and neat. And we're going to make like this little equals line that's going to help us with our math. So I'm going to use a lot of arrows this first time through just because it gets a little funky, but we'll be all right. So the very first thing we do is we bring down the first number. So that becomes a 1. Okay, and then what we're going to do is we're going to take the number up here and that number sitting here, and we're going to multiply. So like I said, it's not even division at all. It's synthetic division, it's fake division. Fake division is multiplication. 2 times 1 is 2. That number goes underneath the next number, the next column. And then this column, we add. Now in long division, we divide and then subtract. I can show you that in class, but so we're doing the exact opposite of each of these. And so -2 plus 2 gives me 0. And now we just repeat the same process. We go start with the 2, times it by this number. 2 times 0 is 0. Add, that number goes here. Add those two together. 1 plus 0 is 1. And then repeat the process again. So one more time with the arrows. 2 times the number that's sitting here is 2. That number goes here. Add them together. A -3 plus 2 is -1. And one last time when we go through it, I'll just show the arrows again. We take this 2, we multiply by the number sitting here. We're multiplying. 2 times -2 is -2. And then when I add these together, I get 0. So now what my answer looks like is this 1, 0, 1, -1, 0. It's kind of odd. Okay, usually what I do before I begin, I put like a little line here. That sort of tells me that this part is my answer. This is my answer. And this part is my remainder. And so that tells me that x minus 2 goes into the polynomial x to the 4th minus 2x cubed minus plus x squared minus 3x plus 2 evenly. There's no remainder, right? But having an answer of 1, 0, 1, -1 does not divide. That did not divide it evenly. So here's what we have to do now is we have to interpret that 1, 0, -1. What we have to understand is that I have one of the x's. I have x to the first. I'm really asking how many times does x go into x to the 4th? But another way of saying this is I have x. How many more do I need to multiply by to get x to the 4th? So it's always 1 degree less. So if we started with x to the 4th, my answer then will be x to the 3rd. And the reason for that is I already had an x. So I'm going to, and then everything just goes down from there. So this 0 then relates to plus 0x squared. And this 1 is plus 1x. And this -1 is just the -1 coefficient. Now, when I read off that answer, I probably would not say this term. So I would read that off as x squared plus x minus 1. That is our answer when you divide that polynomial by x minus 2. So for the next example, example 4, we're going to just go through. I'm going to put the r value in here as -2. This right here is just showing us division, no big deal. Here's my -2. All right, 3, 2, 1, none, we're good. So we go 2, -5, 4, -4, 2. All right, so I bring down the 2. -2 times 2 is -4. Add those together, I get -9. -2 times -9 is 18. 18 plus 4 is 22. -2 times 22 is -44. That gives me -48. So there's that little line there to show my remainder. I started with degree 3. So then this 2 represents degree 2. We always step it down 1. So 2x squared minus 9x plus 22. And then how we're going to write our remainder is -48 over what we were dividing by, x plus 2. All right, we're going to finish the rest of these in class because I ran out of time. I didn't know I didn't have these.